Another slight variant of these classic problems in general methods, the means end analysis. For instance, if we wanted to get to Phoenix, how are you going to get there? Well, I need to get to my car, drive to IAH in Humboldt, Texas, where the H is silent, and take that flight. It's a means to an end. So there might be a half dozen legs that are in between, such as parking in the what do they call that? The parking lot, I think it is, at the Houston airport, and taking the shuttle into the airport, etc., which I've gotten good at. But in this case, everything that you do, all the sub steps, are indeed a means to an end. So we're counting on that. So sub goals are important, and of course, among the sub goals that even would precede me going to the international airport would be to buy the ticket. Your author gets into something at least a couple times in this chapter that's a little opaque. I'm going to do my best to plow through it, but I'm going to make a promise that I'm not going to ask too many questions about it, or maybe none. Just bear with me. What you're looking at here is crypt arithmetic. So what does it mean when they say Donald plus Gerald equals Robert? These are crypt arithmetic problems. What that means is that there are problems where the letters stand for numbers, but you can't exactly tell that by looking. You have to sort of discern that. But the logic in ultimately is a means-end analysis. So this general problem solver uses the following basic strategy. First, it looks at the object as is given, like these names, and compares it with the desired object, such as an arithmetic problem with numbers in place of letters. And then it considers the operations available to change those objects. So the available operations including those that replace certain letters with digits like D equals 5, and it ultimately arrives at an answer. So when this text was written, we did not have AI, artificial intelligence, like ChatGPT, as we do now. And so you can imagine that to some degree, artificial intelligence as we know it is involved in means-end analyses, and it's scary how good it can be. And we professors are now encountering difficulty knowing how to grade papers that may show evidence of having used those things. It's a brand new thing, boy. We don't know where to start, really. So if several very top there, if several possible operations are found, all of which could apply to an actual object, then this, what they call a general problem solver, could has some means of ranking the different operations, such as ones that are used first. So if you'll indulge me just this one paragraph. So these authors gave several problems in logic and crypt arithmetic to both human subjects at Yale and GPS and compared the thinking between them. The human participants generated verbal protocols, much like the ones you have been asked to generate as you read this chapter. GPS, on the other hand, which was automated, produced a printout of its goals, its sub-goals, and the operations it applied as it worked. So comparing the protocols generated, Newell and Simon concluded that there were many similarities between the performance of GPS and those of the Yale students. So the means-end analysis used by GPS is more focused than the generate and test techniques because it gives the problem solver more guidance in choosing which step to take next. So this is narrower and more focused than a straight-up generate and test. So means-end analysis also forces the problem solver to analyze aspects of the problem before starting to work on it and generate a plan to solve it. Now, we can't really see this with something as refined as ChatGPT or something like it, but that is among the things that undergirds that sort of endeavor. And it's really will be interesting to see what happens in coming years, how those things unfold. To tell you the truth, I don't take advantage of those things very much. I'm pretty ignorant of how they work. And I haven't really seen any evidence that students have used it much in any of my classes, but it's still interesting how it may tap into a means-end analysis. So means-end analysis is not always the optimal way to reach a solution, because sometimes the optimal way involves just taking a temporary step backward or further from the goal. For example, imagine you live in an eastern suburb of Los Angeles, as they say on the Andy Griffith Show, but you want to take a flight from Los Angeles to Denver. To do so, you first need to go to the airport, and that means moving temporarily a greater distance further west from your goal than your current distance. So I might make the same analogy. If I wanted to fly to Orlando, I may ironically go a little bit further west into Houston to catch the airport to get there, and that would be undermining the sub-goal of a means-end analysis. But nonetheless, you get the idea. Whether it's sophisticated software or whether it's just people doing it, establishing sub-goals to get somewhere is a little bit more intricate and involved than, of course, a straight generate and test technique. But I promise not to ask you anything about this complex cryptarithmetic business. But to her credit, she goes a long way to demonstrate the technology that she had available in 2018 as she wrote this.